Hello, DE Psychology. So we have a lecture today. We're going to start our sensation and perception lectures. And so I wanted to give you a little bit of background about sensation. As we study the 5 different senses and how they work, there is some commonalities between all of the 5 senses and some common vocabulary that we have that we need to go over. These are basic vocabulary terms, and I wanted to discuss them with you in the form of a lecture. I think that would be the easiest way for us to do things. So, as you take notes, you are welcome to pause me. I'm going to go quickly through this stuff simply because I don't necessarily need for you to wait to write things down. You can just simply pause me. And that way our lecture can be kept to at least 15 to 20 minutes. In addition, there are some videos that I'm going to reference. These videos will have the links in your Schoology folder. I would highly suggest watching these videos in order to understand these terms even more so. So make sure to see those videos, apply them to the terms that they are associated with, and that'll help you learn these terms for our test. All right, so let's go ahead and get started. We're going to talk about sensation. So this is a 2-part unit. Sensation is just 1/2 of the equation because the other half is perception. And we'll talk about perception in the second half of this unit. But let me give you both of these vocabulary terms. Sensation is a process which our sensory receptors and nervous system receive and represent stimulus energy. Okay, the first part is really easy to understand. This is a process where our sensory receptors, whether that's our taste, sight, hearing, smell, or touch, they take in information. That information goes through wherever systems, our nervous system, peripheral nervous system, central nervous system, and into the brain in order to go into the proper area for that energy, whatever that energy may be, whether that be our sight or sound, touch, etc. Goes into the brain, and that energy is then sent to the portions of the brain that are going to do the interpretation. The interpretation is perception. Perception is the process of organizing and interpreting sensory information, enabling us to recognize meaningful objects and events. It's the second part of the equation of sensation, and then the perception of what we are actually receiving through our senses. So this one's kind of fun. Our sensory and perceptual process work together. They help each other out in order to understand things. So this is just a fun little picture where if I tune you in to the sensory, to your sensation of visualization, and I actually tune in your brain to perceive something, then you're going to finally see it. So this is a picture that offhand looks like a cowboy riding through a forest. But this picture is called The Eyes Are Watching Us. And if you can see, you'll find about 10 to 11, I can't remember exactly, different faces that are looking at the cowboy as he roams through the forest. So what I've done there is just taken your sense of sight and informed you of what you should perceive. And now you're able to interpret that sense of sight and perceive what you're supposed to perceive. So we can see different types of faces throughout the forest. Kind of a fun picture. And I think somewhere around 10 or 11 are in there. Our next 2 terms, bottom-up processing and top-down processing. So, bottom-up processing is a really kind of interesting concept. When we bottom-up process, that means we're going to use our senses first, and then we're going to go from the bottom, from our senses, into our head, and we'll perceive. That's the normal way we usually think about things. We bottom up process. We sense, and then we perceive. Versus top-down processing is we anticipate, then we sense. Okay? So, for instance, let's talk about something that might be a top-down processing. Maybe I have this water bottle, if I can grab it, next to me. And top-down processing says to me, Well, I'm going to perceive this as water. So when I open it up and take a drink of water, in my head, I'm going to feel a nice, refreshing taste of water. Yep, there it is. Top down processing, okay? When we construct a perception, drawing on our experience of what water should taste like, then we have a top-down processing. And yes, it tastes like water. It's refreshing. But let's say that this canister wasn't filled with water. Let's say that somebody had filled this with Pepsi. So instead, I may not have a perception of what's in here. And so I go to take a drink. That's Pepsi. Okay. I'm taking sensation first, then going through my head and going, what's that taste? Oh, that's Pepsi. Okay. That would be bottom up processing. Let's do another example. Sometimes when I'm snowboarding, I kind of lose my focus and maybe I catch an edge and I fall. It doesn't occur to me that I've fallen until I have hit the ground and feel the ground, okay? Maybe feel pain. And then I realize, oh my gosh, I just fell, okay? That would be bottom up processing. I'm feeling and then processing what happened. Whereas top down processing might be me anticipating falling and then I hit the ground and feel it, okay? So that's the difference between bottom up and top down processing. The study of the different sensations and how they work and how we perceive these different sensations is known as psychophysics. It's not an extremely big area of psychology, but psychophysics, you can become a psychophysicist, okay? If you were to study any of the senses and how they affect our perceptions. I love this idea. This is a vocabulary term that fits to all 5 of our senses. So this is known as absolute threshold. Absolute threshold is the minimum stimulation need to detect a particular stimulus at least 50% of the time. So each of our senses has an absolute threshold, and I've included on this PowerPoint what that means, okay? So our vision, we are sight-based humans, okay? Our primary sense is vision. So our vision is fairly acute, and at our absolute threshold of most normal human beings, we can perceive a candle flame from a distance of about 30 miles if we are experiencing pitch dark. Okay, so if we're in a tube, basically a vacuum per se of pitch darkness, the human eye would be able to see a glow of a candlelight from 30 miles away. Now, obviously, we haven't ever been able to do this experiment per se exactly in real time. We're able to make some calculations that is the absolute threshold of the human vision. We do those calculations by basically using ratios. Now, our hearing is not as acute as our seeing. Our hearing's absolute threshold is that we can hear the ticking of a watch from about 20 feet away. Okay, we're able to detect that sound 50% of the time when our hearing is typical, and that is its absolute threshold. Smell, about 1 drop of perfume diffused throughout a small house. Taste, about 1 teaspoon of sugar dissolved in 2 gallons of water is about our absolute threshold. And touch, the wing of a fly on the cheek from a distance of about 0.4 inches, we can tell something's there. Okay, so those are our sensory absolute thresholds. Difference threshold is a little different. The minimum difference between 2 stimuli required for detection 50% of the time is what we call the just noticeable difference or difference threshold. It is a term that can be 2 terms synonymously meaning the same thing. I tend to refer to it as the just noticeable difference. So if you were to take an iPhone, maybe an iPhone 8 and an iPhone 11, okay, and hold them in your hands, you might notice there is a difference threshold, that one is heavier than the other, okay? The ability to tell that is that there's an equation of how much it has to differ by in order for us to tell there's a difference. If I have an iPhone 8 and one has a protector on it, and I have another iPhone 8 and the other doesn't have a protector, I may not be able to notice the weight difference between the two phones, even though the one with the protector would likely be heavier. What I would like you guys to do is try to see if you can have your difference threshold to tell musical notes. So people who are attuned to music will likely be able to tell the difference. Those of you that are not as attuned to music and each note and trained in music, you may not be able to tell the noticeable difference. So what you want to do is you want to play this video. This is a video comparing and contrasting a contested song that was sued for copyright infringement. The original artist, which was David Bowie and Freddie Mercury, said that the song that Vanilla Ice used was not enough different in order to constitute him not getting permission and paying royalties to Freddie Mercury and David Bowie. A judge in the court said that there was not enough difference. But you listen for yourself. Do you hear the difference in the notes? All right, so you can pause me and jump in and watch that video, or you can wait till later. But I definitely suggest, as you watch the video, you make sure to remember this is an example of just noticeable difference so that you don't confuse why you're watching these videos. Signal detection theory. Signal detection theory predicts how and when we detect the presence of a faint stimulus amid a background of noise. Okay, so let's say that you're in a really busy room. Let's say like the lunchroom or the cafeteria in a normal year, and the volume is fairly loud. But you're sitting there at a table and you're waiting and expecting your friend to come and get you because you guys are supposed to run to Taco Bell. All right, so this is a theory that says there's not one single absolute threshold, kind of like what we just talked about a minute ago, where it takes one drop of perfume in a small house to detect. This theory says it's all based on your signal detection. So if we're sitting in the cafeteria, we're waiting for our friend, and we know that they're coming, we might be able to hear them from about 30 feet away say our name. Maybe they end up saying, Johnny, just like in that voice. But in the midst of the din of the cafeteria, normally you wouldn't hear it. But because of your expectation of waiting for that person, you hear it. So the signal detection theory says there's not one absolute threshold. It all is dependent on our experience. Okay, maybe we're more experienced of working in a louder noised place, so we're attuned to hearing our name. Our expectation, like me waiting for my friend, wondering where they are, and I can hear them from 20 feet away call my name, which I normally wouldn't be able to, but I'm expecting them. Our motivation, obviously, I'm motivated to hear because I'm hungry and I want to get to Taco Bell. And then, of course, our level of fatigue. Are we super tired? And that may affect how acute our hearing or taste or sight or seeing might be. I said sight and seeing. Two same things. Our hearing, our taste, our sight, our touch, our smell. There we go. Now, another vocabulary term that is oftentimes over-exaggerated is sublimation. So sublimation is when stimuli is below our absolute threshold and it's below our conscious awareness. We shouldn't be able to hear that. We shouldn't be able to pay attention to that or see it because it's below our threshold. In regards to seeing, maybe something is flashed really quick before your eyes. So Sublimination is the idea that maybe there's a part of us, even though we know consciously we didn't detect seeing something or hearing something or tasting it, maybe there's a small part of us that is unconsciously aware that it's there. So, what happened in the 1950s after World War II was sublimination. The psychophysicists were really starting to study the different senses, and sublimination kind of got some good press when a study was done in regards to a hot theater and selling more sodas. So here's what the researchers did. They decided that they would, in the middle of a film that they were showing, splice in a maybe a so many tenths of a second of a word that normally you wouldn't be able to see, but of words that said "you're thirsty." So in the midst of this movie, they wanted to see, does sublimination work? If we flash "you're thirsty," will there be more sales at the concessions of people leaving the theater to go get a drink because they subliminally saw the message, even though they can't say they saw it, they unconsciously saw it because it was flashed so fast. Well, the results came back, and basically the results were that there was a positive correlation, that every time they flashed this quick message, that sales for Coca-Cola and Pepsi and whatever were going up. So it hits the news that sublimination works, and this became very much a fearful thing because we had just fought World War II, and there was a big fear of communism, and so people started to theorize, well, what if movie makers in Hollywood start putting subliminal messages in our movies that are pro-communist, and we all end up turning communist, and this whole nation is ruined? So sublimination had gotten so much press that people were so scared that that's exactly what the Soviet Union was doing, is they were feeding us subliminal messaging. Well, about 5 years later, another group of researchers decided to replicate the study. Because remember, replication is part of the scientific process. If you can replicate it and get the same results, then, well, we're on to something. So the scientists replicated the process. And one thing they found when they started to replicate it is that a lot of the procedure that you normally write down in a good study was missing. And they did the study, and what they found out was there was no real correlation. And what they continued to find out was that, well, the original study that said sublimination works had been done on a hot summer, and there wasn't really air conditioning in the theater. So because there were confounding variables like temperature in the theater and the length of the movie, it was a longer movie, that likely sales at the concessions went up for drinks because of those variables, not because of the sublimination. And so the more recent researchers kind of made the conclusion that sublimination was not something that actually happens. Nowadays, with many other replications of that study and other studies, we know that sublimination doesn't really work. If we don't consciously sense something, it doesn't stick with us just because it somehow overrides our conscious mind. So, just kind of for fun, I've included a video of Disney supposedly subliminal messaging in Disney. So you can take a look at that. That one's just kind of fun. All right, let's go on to two other terms, Weber's law and sensory adaptation. Weber's law kind of fits with the whole just noticeable different, that for two stimuli to differ, there must be a constant minimum percentage. So for instance, in light difference, if I turn on this lamp right next to me, which right now is not plugged in, if I turn on that lamp next to me, maybe I'll plug it in. 1 second. It's taking me a minute. on this lamp in this room, you can see that there's a just noticeable difference, right? And if I turn on this blind in this room, you can see the light added is just noticeable difference. It's differing by a larger percent, okay? But if I turn on this blind first and make it all the way up here, and I turn on the overhead light, you might not notice a difference. See, because the simulation has to differ by a particular minimum amount for us to tell the difference. So for light, we have to be able to tell at least an 8% difference in the lighting. Weight, go back to our iPhones. There needs to be at least a 2% weight difference between the two objects. And then tone frequency, at least a 3% tone frequency difference. The next definition, sensory adaptation. And I'm going to stop for a second. Plug back in my computer. Now, you have much better teachers that know how to edit this stuff, and I don't know how to do that. So hopefully I'll give you a second maybe to write. All right, so sensory adaptation is when we have a diminished sensitivity as a consequence of constant stimulation. So we've talked about this before. We talked about this when it came to our memory of things, how we tend to ignore the feeling of our shirt on our arm or our shoes on our feet. There you go, Jason. There's a good one for you. Hopefully you're feeling your shoes or your socks now. So sensory adaptation is that same idea, is that we talked about when we put memory stuff into our senses. Sensory adaptation is the diminished sensitivity as a consequence of constant stimulation. So if you have a noise going on in the background that initially was annoying you, it may have stopped annoying you. Or many of you, when you go into my room, you initially smell the plug-in, and then about halfway through the class, you can't smell it anymore. That's sensory adaptation. The last slide is talking about something called the McGurk effect. And I feel like the video that I have is going to explain it much better than I can explain it. And some of you have probably seen some of these viral things about the McGurk effect. And now you'll have a vocabulary term to describe what it is that some of these viral things are testing you. So the McGurk effect is when two senses conflict. I highly suggest you watch this video in order to understand the McGurk effect. All right, guys. That's going to be it. We'll be talking about vision in our in-class session days, and you're done with looking at some basic vocab for sensation. Thanks, guys, for watching. Hopefully that wasn't too painful, and we'll see you soon. Bye.